Hello, class. Welcome to the next lesson in 8th grade Eureka Math. We're in Module 4, Lesson 14 today. Lesson 14 is called Graphs of Horizontal and Vertical Lines. Graphs of horizontal and vertical lines. So we are graphing still. This time we're graphing very specific lines. In Lesson 13, we learned about how to graph a line and the shape of a linear equations graph. Well, now we're going to have shapes that are horizontal and vertical lines. So you'll need graph paper, you need your writing tools, and you'll need pages 147 to 153 of your Module 4 workbook. Let's begin, and let's begin with vocabulary. Just a quick reminder, if you need to pause the video anytime, go ahead and copy things down. If you want to go back, because I'm going a little bit too fast for you, go back and watch it again and write down anything you need to write down. Remember, you control the speed of the video, so use it to help you the most. Let's look at the vocabulary. We have 3 vocabulary terms today. First one is a linear equation, which is one we've seen before. A linear equation is a math statement with an equal sign that shows a relationship which graphs as a straight line. So linear equation, math statement with an equal sign. And like we learned in Lesson 13, a linear equation makes a straight line. And the next word is horizontal. Horizontal means going straight left and right. So it's not diagonal, it's not oblique, it is left and right. So a straight line left and right. Vertical means is going straight up and down. So horizontal and vertical are kind of connected. They are not diagonal. Horizontal is left and right. Vertical is up and down. Straight. Very important you know those 2 words because we're going to be talking about them today. We're going to be graphing them today. So we'll see linear equations that make horizontal lines, linear equations that make vertical lines. So far, we've seen linear equations that make diagonal or oblique lines. Today, we're going to focus specifically on horizontal and vertical. So that's the vocabulary. Today, we will learn how to write equations for and graph vertical and horizontal lines. So we're going to write equations for horizontal and vertical lines, and we're going to graph vertical and horizontal lines. So we're writing equations and we're graphing. So it's the same thing we've been doing in a lot of lessons recently. The difference is these are very specific types of lines, horizontal and vertical. So you know what we're doing. Today is just going to be a little bit different with some specific graphs. So I want to do some examples today, but the good thing about today is the examples we're going to do, we're just going to use the exercises starting on page 147. So for the examples today, we're just going to get straight into the exercises, start doing the math with the exercises, and the exercises on page 147, those will be our examples. And that's the end of our note page. Like I said before, if you need to go back and rewatch anything or copy anything down because I went a little bit too fast, go ahead and do that. I won't be offended. But right now we're going to move to page 147 to do the exercises so that we know what's up. So you'll see the exercises on page 147 are in 4 groups. We have exercise 1, 2, 3, exercise 4, 5, 6, exercises 7, 8, 9, and exercises 10, 11, and 12. So we are going to do each group separately. We're going to start with the first group, exercise 1, 2, and 3. Now what it says is find at least 4 solutions to graph this linear equation. So we need to find 4 solutions to graph that equation. So we need to find solutions, which means we need to build our table, and then we graph. So let's do that. They did not give us a whole lot of room on here, so I'm going to do the work on a piece of graph paper. So let's see, let's label the paper exercises. And we're going to do exercise number 1. Exercise number 1, we need to build a table. So let's build our table. And we need, so let's see, I'm going to put my X here. I'm going to leave room for my equation in the middle. And I'll put my y over here. And they said we need 4. So I'm going to leave room for 4 values to graph. So 4 values to graph. So 4 x's to make 4 y's. That's my table. Let's see, the equation it wants is 1x plus 2y equals 5. 1x plus 2y equals 5. Looks good to me. Now, I'm going to start by doing this, and because y has the more complicated coefficient, 2 is more complicated than 1, I'm going to start with my values for y. I'm going to do, let's see, what I like to do is, because we only need 4, I'm going to spread them out a little bit. So I'm going to do, let's say, -3, -1, +1, and 3. Now you can pick any values you want. That's just what I'm picking. So you can choose the values I chose, or you can choose something else. But after we do this, let's solve the equation. So we get x plus 2 times -3 equals 5. That's x plus -6 equals 5. So x is going to be, remember I use the addition property of equality, add 6 to both sides. X is going to be 11. Okay, now what happens when y is -1? I do x plus 2 times -1 equals 5. That gives me x plus -2 equals 5. Well, I use the addition property of equality, add 2 to both sides. I find out that x is going to be 7. Okay, what happens when y is 1? I get x plus 2 times 1 equals 5. That's x plus 2 equals 5, so x has to be 3. Okay, what happens when y is 3? That's x plus 2 times 3 equals 5. That's x plus 6 equals 5. Well, what plus 6 equals 5? It's going to be -1 plus 6 makes 5. So now we have coordinates, 11 and -3, 7 and -1, 3 and 1, -1 and 3. Because remember, our coordinates need to go in the order x, comma, y. So I have my coordinates. Let's graph it. Let's graph this. So I need to make sure that I have enough room. So my x's go from -1 to 11, and my y's go from -3 to 3. So I think I can probably fit it right here. I'm just going to do a straight line like that for my x's. And because I know x has to go to -1, I'm going to make some room for negatives. So I'm going to put my y-axis right here. There's my y. Now I'm ready to label. That's the origin. So let me label my intervals. And my -x intervals, my -y intervals, and my +y intervals. There we go. X is built, and you can see that I planned it out pretty well. So I have all these x's are on the graph, and all these y's are on the graph. Let's start graphing. First one, 11x and -3y, so it's right there. 7x and -1y is right here. 3x and 1y is right here. And -1x and 3y right there. So there's my graph. And I'm going to connect the points. I drew my coordinates. Now I'm going to connect them to show you my line. There's my line for my linear equation. So that is number 1. It wanted me to find at least 4 solutions. I found 4 solutions. I put them in a table. I found my coordinates, and I graphed it. I'm done with number 1. Let's see what it wants us to do for number 2. Number 2 says find at least 4 solutions to that graph of the linear equation. So I have to do another graph. So I need another table for number 2. So let me get my table ready for number 2. So again, I'm going to build my table. And I'm going to use the top one as a model because I still need 4 points. So there's 1 coordinate, 2, 3, and 4. 1 top row to label everything, and 4 rows for my 4 coordinates. Here's my x, here's my y. The equation goes in the middle, and the equation for number 2 was, let me find it. The equation for number 2 was 1x plus 0y equals 5. Okay, so 1x plus 0y equals 5. And now I'm going to solve this one and graph this one. You know what I'm going to do for this? Just to keep it simple, I'm going to use the same y's that I used in the number 1. I'm going to use just the same y's. -3, -1, 1, and 3. And we'll see what happens with those. So this is the equation I need to use. Let's substitute. X plus 0 times -3 equals 5. That means x plus 0 equals 5. So x is going to be 5. This is x plus 0 times -1 equals 5. That's x plus 0 equals 5. So wait, x is 5 again. Curious. Let's try this one when y is 1. X plus 0 times 1 equals 5. Well, 0 times 1 is 0, so I get x plus 0 equals 5. X is 5 again. Make a prediction. What's x going to be for this one? X plus 0.0 times 3 equals 5. That's x plus 0 equals 5. X is 5 again. Well, for this equation, every y I picked had the same x. Every y I picked had the same x. Let's graph this because it's kind of curious. So let me draw my graph again. Oh, wait. First, let me write my coordinates. Should change my solutions into a list of ordered pairs. 5, -3, 5, -1, 5, 1, and 5, 3. Let's graph this. So I'm going to draw my axis again. Just like that. I'm going to go with my x and y axis. There's y, there's x. There's the origin, which is 0. Let me label my intervals, my positives and my negatives. Build my graph. There we go. The xy axis is complete. Let me label. So 5x, -3y. Here's 5x. Here's -3y. 5x, -1y. 5x and 1y. 5x and 3y. Well, look at that. Now when I connect them, I just made myself a vertical line. Remember from our definitions, vertical means straight up and down, straight up and down. So this is vertical. That's vertical. Why do you suppose that's vertical? What changed between these two? I mean, if you look at the equation in our tables, they're pretty close. We have 1x plus 2y equals 5. We have 1x plus 0y equals 5. What changed between our red and our blue graphs? What changed? Well, hopefully you noticed that the coefficient with y changed. The coefficient with y changed. In this graph, it was 2. In this graph, it was 0. When y's coefficient was 0, we made a vertical line because y does not change. Y does not change, which means x is always going to be 5 in this. Y has a 0 value. So because y changes the vertical, x is always 5. X is always 5. Question 3, what was different about the equations in exercise 1 and 2? Well, we just talked about that. The y coefficient was 0 in number 2. It made the graph vertical. It made the graph vertical. So when there is no y, when y goes away, because 0 times y makes the y go away. So we can even cover it up. I cover it up with this. When the 0 times y in the equation makes the y go away. So we just get x equals something. So when we don't see y, when y goes away, we have a vertical line. When there is no y, we have a vertical line. So that is something we learned. That is something we learned. Let's add it to our notes right here. Let's add it to our notes. Let's add it up here. Let's add it to the bottom of our page. Let's do takeaway number 1. No y in a linear equation means a vertical line. No y in a linear equation means a vertical line. No y, here, let me do it in a different color. No y means vertical. No y equals vertical. Let's see what happens with, that's the first group. That's number 4, 5, and 6. Let's try that was the first group. That's number 1, 2, and 3. Now let's try 4, 5, and 6. So let's graph again. Let's start down here underneath number 2. Let's do number 4. Number 4, we want to graph the linear equation x equals -2. So let's build a table again. Let's build a table. And we're going to graph x equals -2. So we're building a table because that's how we organize our coordinates. So we put x values over here, y values over here. And the equation is x equals -2. X equals -2. So, let's start with the y's again. Let's use the same ones. -3, -1, 1, and 3. Why not? Just keep it simple, use the same ones. Well, this one, x equals -2. So what happens when y is -3? Well, x is -2. X equals -2. What happens when y is -1? There's no y over here, so x is -2. See how the equation just says x is -2? That means when y is -3, x is -2. When y is -1, x is -2. When y is 1, x is -2. When y is 3, x is -2. So it doesn't matter what y is, x is always -2. So when we graph this, we can let's just do a simple graph. Let's do whatever that is and whatever that is. Let's graph this. So we have y-axis, x-axis, the origin. Let's label our intervals positive and negative on the axis for x and y. There we go. We built really quick axis. So, oh, I forgot my coordinates. I have -2 and -3, -2 and -1, -2 and -2, -2 and 3. So graph this. -2, -3, -2, -1, -2, -2. All right, did I do something wrong? -2 is -3, -2 is -1, -2 is -2, -2 is and 3. Oh, I did this wrong. Oh, this is -2 and +1. That's my confusion right there. I must have gotten fast. So this one goes, it actually probably doesn't matter because you can see I made a mistake right here. That should be a 1. My bad. But you can see from this that all of the answers were -2. So they all just go on the same vertical line. They all just fit on the same vertical line. And this fits with the takeaway we had. Remember, the takeaway was no y means vertical. In this equation, there was no y. So we're going to get something vertical. And we know where it goes because the no y means vertical, and it's always going to be where x is -2. So we can even know where the vertical line goes. If you remember number 2, there was it was x is 5, which means there's a vertical line always at the 5. For this one, there is no y, so it's vertical, and x is -2. So the vertical line is at x equals -2. That's number 4. For number 5, it says graph the equation x equals -3. Okay, well, let's do that. I'm going to get another piece of graph paper because I ran out of room on that one. But for number 5, let's see. Let's label the paper. Exercises continued. And we're going to be doing number 5. So here's number 5, and we need to build a table for number 5. Because it's always good to be organized right now. Just while you're still learning this, build your tables. Some of you are thinking, I already know where this graph goes, Mr. Baylor. Why do I need to build a table? Well, you're building a table to keep the same pattern going, just to double check. It's not just about building the table this time. It's about being organized and knowing how to build it always. So for number 5, it was x equals 3. So our equation is x equals 3. Well, let's pick some things for y. Let's do, I don't know, for this one, it doesn't even matter. Let's do 72. Let's do 42. Let's do -831. Let's do 9,458.5. Because it doesn't matter what y is. You can see it does not matter what y is because there is no y here. Whatever y is, this is never going to change this because there's no y in the equation. So the y's change nothing. It's always x is 3. Always, 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 because there's no y's here. So when we graph it like this, building a quick graph. And if you cannot build a graph this fast, just keep practicing. Remember, we draw the axes, we label our axes, and we write the intervals. Whatever we do, x is going to always be 3. So the line here, I don't even need to write my coordinates because I know there's no y, so it's vertical, and it's always x equals 3. Always, always, always. X equals 3. Y is 0, x is 3. Y is 1, x is 3. Y is 4, x is 3. Y is -4, x is 3. No matter what y is, x is always 3 because there's no y in the equation. There's no y in the equation, so x is always 3. So what will the graph of x equals 0 look like? Well, the takeaway, no y means vertical. No y means vertical. So you know what will the graph look like? It will be a vertical line, and it will be vertical crossing the x-axis at 0. Because if you remember this one, x plus x was 5, so it was a vertical line crossing at 5. This one, x equals -2, was a vertical line crossing at -2. Number 5, x equals 3, was a vertical line crossing at 3. So when x equals 0, it's going to be a vertical line crossing the x-axis at 0. So that's how we make vertical lines. To make a vertical line, just no y's. No y's make vertical. No y's make vertical. So those of you paying attention can probably guess what's going to come next with the group 7, 8, and 9, because the title of the lesson is Graphs of Horizontal and Vertical Lines. So we just did vertical lines. What do you think is coming next? That's right, candy. No, not candy. We did vertical, we're doing horizontal. Maybe we want candy. So for number 7, find at least 4 solutions to graph this linear equation. 2x plus 1y equals 2. So let's do that. So for number 7, build another chart. Leave room for a heading, and then for 4 coordinates. So 1, 2, 3, and 4. Let me finish making my table real fast. If your table looks better than mine, congratulations, but I'm just making it super fast. There's where my x coordinate goes. There's where my y coordinate goes. My equation goes in the middle. And let's look at number 7. The equation was 2x plus y equals 2. I'm just going to put 2x plus y equals 2 because 1 times y is just y. So I'm going to put 2x plus y equals 2. 2x plus, got it right. Okay. Now, because x has the more complicated coefficient, 2 is more complicated than 1, I'm going to pick my values for x. And again, just because I want to, let's do some -4, -2, +2, and +4. You could pick any 4 you want. Those are just the ones I did. So x is -4. So I do 2 times -4 plus y equals 2. That means -8 plus y equals 2. Remember, to isolate the y, I do the addition property, add 8 to both sides. 2 plus 8 is going to be 10. For x is -2, I can do 2 times -2 plus y equals 2. That's -4 plus y equals 2. Add 4 to both sides, y is going to be 6. When x is 2, I get 2 times 2 plus y equals 2. That's 4 plus y equals 2. Well, this time I have to take 4 away from both sides to get y by itself. So 2 minus 4 is -2. When x is 4, I get 2 times 4 plus y equals 2. That's 8 plus y equals 2. Take 8 away from both sides. This turns into 0, and this turns into -6. So now I write my coordinates, and remember the coordinates go in the order x comma y. Let me write my ordered pairs. I get -4 and 10, -2 and 6, 2 and -2, 4 and -6. Now I need to build my graph. Now my graph, if you look on the x's go from -4 to +4. So I'm going to need to spread out my x's a little bit. I'm also going to have to spread out my y's because it'll go from 10 to -6. So I need to probably start right about here for my graph. I need +10 y. So I need to go down probably about that far for my top of the y's. And I need to go down at least to -6. So here's my axes. Let's see if I can fit all on the camera for you. There I go. Here's my y-axis. Here's my x. There's my origin at 0, 0. Let's label everything with, let me label all my intervals so it's easier to read. Hopefully, I think I fit all of these on here so that I can graph my coordinates. There we go. Okay, so we have that graph right there. Let's start graphing our points. -4x and 10y. So here's -4x. Here's 10y. They meet right here. Then I have -2x and 6y. They meet right here. 2x and -2y. Here's 2x. Oh, I dropped down to -2y. And here's 4x and -6y. So 4x and drop down to -6. There's my 4 coordinates I made with my 4 ordered pairs. Let's connect them. There is the line I made. So that is the line for 2x plus y equals 2. That's that line. Awesome. Let's now change it a little bit. Let's see what number 8 wants us to do. Number 8 is asking, find at least 4 solutions to graph the linear equation 0x plus 1y equals 2. So now we have a different equation. Just to save some room on this, how about I do number 8 on the same graph I did for number 7. So let's just build a new table underneath this one. I'm going to do number 8's table right here. Let's put a new table for number 8, and let's hope I built it correctly. 1, 2, 3, 4, 5. I need to make my columns for x and y and the equation. There's the x column, there's the y column. And let's remind me of the equation. The equation for number 8 was 0x plus 1y equals 2. So I have 0x plus y equals 2. Okay, good enough. Now I'm ready to go. And again, just like for number 7, I started with the x's. Let's start with the x's again for number 8. Let's do -4, -2, 2, and 4. We'll just use the same x values we used for number 7. Well, this equation is 0 times -4 plus y equals 2. Well, that turns into 0 plus y equals 2. So y is 2. X is -2, so 0 times -2 plus y equals 2. That turns into 0 plus y equals 2. So y is 2. X is 2 now, so we do 0 times 2 plus y equals 2. 0 times 2 is 0, so we get 0 plus y equals 2. So y is 2. And x is 4. 0 times 4 plus y equals 2. That turns into 0 plus y equals 2. So y is 2. Well, looky there, peoples. Looky there. X changes, but y doesn't. And that's because there is no x. X is not here. x could be anything, but it always changes to 0. So in the first group of questions, we had y go away. In this one, x gets multiplied by 0, so x goes away. So we always have y equals 2. Y always equals 2. What kind of line is this going to make? What kind of line will this make? When the x went away, we got a vertical line. I'm sorry, when the y went away, we got a vertical line. What kind of line do you think we're going to get when the x goes away? Well, if you're paying attention to the name of the lesson, you probably know. But let's graph this just to confirm. We're going to write our ordered pairs, x comma y. We get -4 and 2, -2 and 2, 2 and 2, and 4 and 2. Let's graph these on the same graph right here. So we get x is -4, y is 2, x is -2, y is 2, x is 2, y is 2, they meet right there. X is 4, y is 2, they meet right there. So on this one, look at that. This one is 0x plus y equals 2. Wow, look at that. I think we have another takeaway. We need to add to our chart at the bottom. Takeaway number 1 was no y in a linear equation. It means a vertical line. So I think takeaway number 2 will be no x in a linear equation. Means, and remember this line is going straight left and right, straight left and right. And if you remember back to our vocabulary, straight left and right was horizontal. So no x in a linear equation means a horizontal line. So no x means horizontal, so we can summarize with no x equals horizontal. We got 2 takeaways in this lesson. Make sure you have both of those written down. Pause the video if you need to copy them down again. But no x means, so no y means vertical, no x means horizontal. So number 9, what's our summary for number 9 then? Number 9 is saying what was different about the equations in lesson exercises 7 and 8. So this time for 7 and 8, the x coefficient was 0 in number 8. And what did it change? It made the graph horizontal, straight left and right. There we go. So let's practice more with these horizontal graphs. Let's practice more with horizontal graphs. Number 10, 11, and 12, our last set of exercises. So for number 10, we need to, it says to graph the equation y equals -2. So let's do that. Let's build another table. I'm going to need a third page because I'm not writing on the back. If you want to save some paper, you can always write on the back of your graph paper. But here's exercises, and we're continued onto a third page. And we're going to do number 10. Number 10. Let's build a table for number 10. 1, 2, 3, 4, 5, and make it line up. Connect it. Build my rows. Build my columns. Label my columns with X. Label my columns with Y. And this time we're supposed to do y equals -2. So the equation is y equals -2. So let's start with x's again, and let's just start with the same ones that we used before. Let's do, what do we use before? We use -4, -2, 2, and 4. Well, when x is -4, y is -2, because there's no x here. Well, what happens when x is -2? It doesn't matter, because x is not here. So y is -2. Okay, what happens when x is 2? It doesn't matter, there's no x. So y is -2. Okay, I get that, but what happens if x is 4? Doesn't matter. There's no x in the equation. So y is just always going to be -2. All the x's just turn into y is -2. So let's graph this. Let's graph this. I'm just going to do it like this. And I'm going to put the arrows because the axes go. I'm going to label my axes, y and x, label my origin, and label my intervals. And so, oh, I forgot to make my list of coordinates. I'm forgetting a step. Make my list of coordinates. This is -4, -2, -2, -2, 2, -2, 4, -2. Okay, let's put those. X is -4, y is -2. X is -2, y is -2. X is 2, y is -2. X is 4, y is -2. Well, look at that. Just like we said in our takeaway. There's no x, so we get a vertical line. Y equals -2. Excuse me. That's all we had to do. Y equals -2. Now, let's see. There's no x, so we have a horizontal line. And where does the horizontal line cross the y-axis? It crosses at -2. No x means horizontal, and it crosses at -2. Let's keep going on this. Let's try, because I think on number 11, it wants us to graph the equation y equals 3. Y equals 3. Now, just to save some paper, I'm going to just use the same graph. I'm just going to make a different table. So same graph, different table. And this is something you can do also. If you want to save some space on your paper, you don't need as long as it doesn't get too crowded on your graphs, you can use the same graph for multiple equations like I'm doing. So let me show you how to do that. So we have x, we have y, and for number 11, they wanted y equals 3. So let's do y equals 3. Okay, so for this one, y equals 3, we're going to do, we pick our x's again, and again, it doesn't really matter. So we can do x is 13, x is 1 1/3, x is 1,000,000, x is negative apple, x is negative apple. Because it doesn't matter, because there is no x in the equation. Y is 3, y is 3, y is 3, y is 3. X does not matter. Y is always 3. Y is always 3. So y always has to be 3. So whatever x you pick, y is always going to be right there. Y equals 3. Always. And if you notice, I did a couple things when I used the same graph. I used different colors to make it obvious. I also labeled them so that they're obvious. So if you're going to use the same graph, if you're going to use the same coordinate grid for two equations, it helps if you color code your equations and label your lines with your equations. So you're allowed to use the same graph for more than one equation. Just make sure you either color code and label, or at least label. So label if you're going to use the same graph. But you can see number 10, y equals -2, was a horizontal line that hit -2. And y equals 3 was a horizontal line that hit 3. So if there's no x, we get a horizontal line. That's our takeaway. So number 12, what will the graph of y equals 0 look like? What will that graph look like? Well, that is going to be, it will be a horizontal line because there's no x. So no x means horizontal. That's our takeaway number 2. So here's our 2 takeaways. No x, so there's no x. So we get a horizontal line. And where does it cross? Crossing the y-axis at 0. Because y is 0. So it hits y at 0. So that's our 2 takeaways for today. So that's how we can do vertical and horizontal lines without even graphing. When you get really good at this, when you can memorize these 2 rules for number 6 and number 12, when you can memorize how to graph vertical and horizontal lines, you don't even need to build tables anymore. Because these tables are only useful if you cannot remember and do it in your head. Right now, I want you to keep practicing building these tables and then graphing. But more and more practice, you'll be able to recognize and use horizontal and vertical lines much easier. So make sure you have our 2 takeaways right here. If you missed anything, if you need to rewatch anything, go back and rewatch the video. That's perfectly fine. But now let's talk about your work for the day, starting on the next page, which is the lesson summary, which really you can just use the 2 takeaways we wrote on page 147 is kind of the lesson summary. It's the lesson summary is our takeaways on 147. On 149 is your exit ticket. Let's slide that to the back because that'll be the last thing we do. Oh, exit ticket has 2 pages today, so slide both those pages to the back. But next on page 151, you'll see homework helper that gives you more information about horizontal lines, and number 2 is a vertical line. So look at that if you want a little bit of a review. And the homework helper is on 151 and 152. Page 153 is your problem set, and there are 6 questions on your problem set. It's going to ask you to graph. So what you do is it tells you these substitutions. Take those values and put them in the standard form equation. Graph it. It says graph it. For number 2, graph these. Put these numbers in the equation. So you need a graph for number 1 and a graph for number 2. And then graph this equation. Now, if you can do this without a table, try doing this without building a table. And also you can try to graph number 4 without a table. And then number 5, y, explain why the linear equation y equals c is a horizontal line. Explain why you get a horizontal line when there's no x. And for number 6, explain why there's only one line with the equation y equals c that passes through the point 0c. So explain your learning for today for number 5 and 6. That's your problem set. And remember, my answers to the problem set are online on the Google Classroom. So you can check your answers with mine just to make sure you know what you're doing. And then when you figure you know what you're doing, move on to the exit ticket or move back to the exit ticket, which was on page 149. And on the exit ticket, they're nice enough for you for number 1 and number 2 to give you the coordinate grids, and they label it for you. You just have to graph a linear equation where you use these numbers in the standard form. And for number 2, you graph in the standard form using those values. So substitute and make a graph for number 1 and number 2. But your exit ticket has 2 more questions. Number 3, where you get to write your own equations. So number 3, write an equation that represents the graph line that coincides with the x-axis. So in other words, for number 3, wants you to write an equation for a horizontal line. Write an equation for a horizontal line. And for number 4, write an equation for a vertical line. So they don't want you to graph for number 3 and 4. They just want you to write the equation. One equation for a horizontal line, one equation for a vertical line. Could be any equation you want as long as one is horizontal and one is vertical and you know the difference. That's the lesson for today. That's your exit ticket, which you're going to take a picture of and turn it in on the Google Classroom. Take a picture of both pages, please, or front and back, whatever you have. And then remember, ask me for help if you need any help today. I am here to help you. You just have to reach out and ask, and we'll work together on it. But good luck, work hard, have fun, and I will see you next time.